The paper that I just led is entitled Galaxies Going Bananas. It has its roots actually in work that Edwin Hubble did 100 years ago, where he definitively established a study of galaxy formation by classifying nearby galaxies into different types. And he came up with a very famous diagram that we call the Hubble tuning fork diagram. And on one end of this diagram, you have elliptical galaxies, like a perfectly round ball of dough. On the other end of this diagram, you have spiral galaxies, and these you can think of as an analogy like pizza pies. And we recently used observations from the James Webb Space Telescope to show that most galaxies in their early universe, galaxies that we think are the progenitors of our own Milky Way, are actually not shaped like either of these types of things that we see nearby. They're not balls of dough and they're not pizza pies. They're actually like breadsticks. So when you see a bunch of galaxies in projection on the sky, you want to measure essentially their aspect ratio. And then you plot the aspect ratio on the y-axis and then the sizes of the galaxies on the x-axis. For the galaxies that look like breadsticks or baguettes, they trace out a banana in this diagram of aspect ratio versus size. So that's the inspiration for the title of the paper, Galaxies Going Bananas. Galaxies are embedded in something called the cosmic web, the skeletal backbone of the universe, made of dark matter. And there's filaments, very long filaments of dark matter in the cosmic web that galaxies are embedded in. And it's along these filaments that mergers with other galaxies happen, that gas accretion happens. And so we think that we're seeing a lot of these elongated objects in the early universe that are, with their shapes, stabilized like that because they live in dark matter filaments. These observations strongly suggest that there is something missing in our standard model of how galaxies form. We observe that 50 to 80% of these distant galaxies are shaped like breadsticks.